Hello, everyone. Hello, and welcome to a Crazy Tek Talks. I'm your host, João, but you can call me Tek. Today, we are venturing into the complex yet fascinating world of code refactoring. We'll discuss its significance, the signs that signal a need for refactoring, and the tools that can make the process more efficient. We'll also dive into some common challenges developers face during refactoring and how to effectively manage them. Whether you are a seasoned developer, a programming novice, or simply a tech enthusiastic waiting to gain a deeper understanding of what goes behind the scenes in software development, I'm glad that you have tuned in. Let's unravel the art and science of refactoring together, so sit back and relax. Let's get started. Okay, so today in this podcast we'll be talking about refactoring. Why today and why I've been off first? Okay, I've been off because I was sick. Like last week, I was really sick. I got the flu. Yeah, it happens. And I'm better right now, but not 100% better. So if I sneeze or anything, this is just a disclaimer, so I'm sorry for any inconvenience. I will try to edit out on editing the video, but uh, it can go through without me noticing it. So I'm just advising it right now. So I was sick and I got to rest. I feel better now. Really, compared to how I was, I'm feeling really better. So, why this topic in the first place? It's not a question, but why this topic? This topic, like, on a call that I had with a developer yesterday, we talked about this. Like, for example, Phantasma chain, the Phantasma ng repository, it really needs a in-depth refactoring because it's a whole mess. It has a lot of functionality, it has a lot of things, but for new developers to get into, it's hard. It's not easy, it's not a straightforward process because we have like huge chunks of classes that goes to 3,000 line. Like it's a lot. And it's not one class, it's a lot of classes, and we kind of don't follow a really coding pattern. So I think the refactoring process will start. It was planned already, but it will start like while we integrate new things, for example, new features, or if we encounter a bug that needs to be fixed. This will be like top priority. Like while we're doing the debugging and assessing the problem, we will refactor along the way. So we will not refactor like everything at once. So that's that. So I think I will like start with the questions because it's a lot of questions, and I think it covers a lot of things that goes into refactoring software. Sorry, I'm still sick. Can you explain what refactoring is in simple terms? So basically, refactoring is when you develop a product. What you do first is when you develop something, the first thing that you develop, the product that you develop at the end, the yeah it won't be in their perfect state, basically. So you develop a feature, it's rough, it's not polished, it's with a lot of, not noise, but with a lot of things that could be rearranged in a certain way that make the code look better for future developers to like look into it, debug it, make adjustments, make a new feature out of it, and like uh use it, understand it. And if you don't understand the code, you can't add upon the code. And basically refactoring is the process that developers do when you have a product that's working and they improve it, like improve the structure for other developers to read it and make like a concise pattern, so you know where the things should be and how they are structured, so it's easier to navigate the code. So yeah, and it's easier to understand. Yeah, I think this question is answered. What are the primary reasons for refactoring the code? Like, the primary reasons for refactoring the code is to have a code that you can understand in like, not right now, because right now you will understand, but once you go away to another project and come back, you should be able to understand it really quick, and you should be able to adjust or add things on top of the project. And refactoring basically allows you to do that faster, like adjusting the code to make it easier to read, to make it easier to navigate, to debug. Yeah, like if you have 3,000 lines in a single file, it's hard to navigate that file. It's not easy, I can tell you. It's like, it's a lot of methods, you get lost around and you don't know where the bug or the feature that you need to implement, if it's already implemented, because that's a lot of lines of code, that's a lot of methods. And yeah, you should restructure the code in that sense. Like, you shouldn't have like for example, in Phantasma we also have like a method with 400 lines, and that's a lot. It needs refactoring ASAP, like really. So and that's just examples. Next question. I think like this question, code almost always needs to be refactored, because the first time that you do the code, you don't do that code in a polished, perfect way. It's almost like a miracle if you do that in the first developing like that function, for example. You can try, of course, to do your best, but it will always need refactoring. Not always, but it should be refactored from time to time to keep up to date the methods. How can we tell when code needs to be refactored? Oh, that's easy. A lot of lines of code, if it's deprecated, like if you are in a legacy software, it most likely need to be refactored to a newer version, to a more stable version, to be up to date to the modern standards. Like if you develop a product in 1980, something like really old software, like it needs a refactor like right now, because in the past we didn't take advantage of multi-threads or stuff like that, because computers were like, the processor was like single threaded and wouldn't take advantage of multi-threaded applications. But right now, like, we have a bunch of cores, threads, yeah, and like software could take advantage of those things to be faster, to fetch data from databases, to compile data. Like, yeah, I think how can we tell? I mean, like, by the lines of code, like if a method has a lot of lines of code, it should be refactored. Sorry, the indentation of the if statements. If you have like Linus Seth, the Linus Torvalds, I think it's Linus Torvalds, the creator of Unix, Linux. He says like if you have more than 3 indentation, 3 tabs in your function, yeah, you are screwed. You should refactor that ASAP. So yeah, and like the number of lines of a function, the indentation, and the what's called it, and the lines of code of a class. Yes, and you shouldn't have like classes inside, like multiple classes inside a single file. It's not a really good way to develop software. Everything should be into its own thing. And one principles, if you really want to get into clean code, I highly suggest that you should check Uncle Bob or Rob C. Martin. It's the creator of the book called Clean Code, and you should look into that. Yeah. Next question. Could you discuss some common signs of code smells that indicates the need of refactoring? Yeah, like variables that are like magic numbers. We call them, it's not variables, but we call them magic, I think it's magic numbers, that are numbers that are in the functions that are not assigned to like a constant or a static value that you can, okay, oh, this is like the fee percentage of something. No, and yeah, it happens, and you should, like, in that case, you should refactor that code. Like, some people are against it and some people are in favor of, like, comment your methods, like not comment the whole method like line by line, but at the top you can do like a Java doc, or in C#, you do the 3 slashes, and you can add like descriptions to the things that will simplify, like, the other developers that will check your code will see, okay, this function does this, so nice, I understand, like let me look line by line. Okay, it's easier to understand. And yeah, like, there's a lot of signs of code smells. One of those is like the number of lines, the methods, naming schemes. Like, if you don't have a like proper naming scheme, you should have, because the naming of the function should be self-explanatory as well. Plus, naming of variables, you should stick to a pattern. Yeah. Like, let me think, like something. Every class in its separate file. Don't do like a single file with tons of classes or structures. No, yeah. If you want to traverse your code, you can do it by yourself. But for other people to understand your code, it's not a good way of structuring it. Yeah. Number of lines, indentation, naming, like, yeah. And if it has bugs, you should refactor right away. Like, you need to go into that. And if it's harder to debug it, you should refactor, because if it's harder, it's not simple to read and it's not simple to track the issue. So yeah. Okay, next question. Can you outline the steps involved in the refactoring process? So there's a lot of ways of doing that. The first thing is, if it's hard to understand the method, okay, the first thing is spot what method or class or anything that you want to be refactored. Like, you want to refactor a whole system, you should take it like simple steps, not everything at once, because that's painful, and you then take like you will feel really bad after like a day or two that you were not able to do the whole refactor the way that you wanted, because it takes a lot of time. Sometimes refactors takes months, because in the process of refactoring it can break things, and that's one of the questions I had. So the steps is like, Okay, let me think like names to be clear. So spot the thing that you want to be refactored, then divide it into small chunks, then write the code. Okay, if you are on a team, make a PR, do a code review, and don't forget about tests. Unit testing. I know it's weird for some people, but if you write tests that can test that stuff that you did, it will make easier for debugging in the future. So you can have a CI, continuous integration and continuous delivery, CI and CD, to like run the tests automated, and if it breaks, it wouldn't and it shouldn't go to production. So yeah, so write tests. I do it sometimes, and like I know I should do more. Yeah, I know I should do more, but while you are refactoring, you should do tests. That's one of the top things you should do. Okay, let's go to the next question. How can we ensure that refactoring does not yeah, I told you. How can we ensure that refactoring does not introduce new bugs into the system? If you have unit tests that you can test things, if you do the refactor, the output should be the same. Okay, so you kind of prevent that thing, and you don't introduce new bugs to the system, and you should do extensive testing to the things that you develop before putting into production. Yeah. Okay. Next thing is, what tools or techniques are commonly used in refactoring? Actually, I don't know the tools. I only know techniques. Like, you can follow some principles like clean code, clean architecture, and follow some books. For example, design patterns for high quality automated tests. I think if you follow like automated tests in your refactoring, because adding tests to the software, it should be considered refactoring, because I know that they were not there in some cases, and you added that to ensure that in the future that function should behave that way. And if someone does change some method that your method was dependent on, you will be warned, and the problem will be spotted before like any major thing that will arise. And the other book that I highly suggest is also Clean Code from the Robert T. Martin, and the other one, the Clean Architecture. I think you should have always these three books in mind. And of course, cybersecurity. While you're developing, you should always have like a sense for thinking not outside of the box, but thinking like an hacker, and what can you do to prevent the hacker to gain access to certain things. So you should consider like implementing things to destructure like strings that come from the outside, human input, that can influentiate the app. So you remove, for example, in a website, you remove the HTML entities. You also try to prevent cross-site scripting, and like in terms of if you insert some data into the database, you should use like some highly advanced mechanisms that you don't input the query. Like you can use ORMs, object relation model, to interact to the database without like actually doing a proper SQL query. So you don't introduce like the possibility of manipulation by the user. And for them to delete stuff or for querying inappropriate things. And you should always have that like in mind. Like you should always think like you should try to always think from an hacker perspective, so you will develop the best software that you can. And of course, we are always prone to being hacked someday or another. But if you try to think like one, you'll develop software that they wouldn't be able to hack it. You understand? I think I made clear, like you shouldn't like have obvious exploits into your code. It can happen, of course, but you should try to always mitigate and do it as soon as possible. Like if you have an API, you should on the controller, on the API call, you should in there have like a method or something to filter the input, filter all the input, like remove any possible thing and throw errors if you need to the API, so the user wouldn't take advantage of that. Okay, how can unit testing support the refactoring process? Yeah, unit testing, like I said, like unit testing is really important, and integration testing as well. Unit testing is really important, so you know that like your core types and the types that you created, classes, structures, anything, will be like they will be always the same, and they need to be according to that. You can use like I think it's black box testing. It's not the most widely used. That testing mechanism is basically you create the tests first and then you create the software. So you have like a sum method, like for example, you have a sum method that sums two numbers, to variables, that you give to the method, and it returns the sum. So you create like the actual unit testing first before creating the method. Yeah, I'm not 100% in favor of that, but in some cases that could be really beneficial. If you know the actual output of things, you can write the tests before writing the software. It's not my favorite way of doing, but you can. Now, okay, unit testing supports yeah, it supports because it ensures that the software will be the same. Yeah, 100%. Next question. Can you share some real world examples of when you found refactoring particularly beneficial? Okay, I can tell you that I will be refactoring two softwares that were developed, and I already refactored them. Okay, I can tell you, like, for example, the farming DApp that I coded for Phantasma. That application, that decentralized application, was amazing. It was amazing to develop in the first place, but I had some issues, a lot of issues. And I refactored the first time, okay? And I made it better. I had an admin panel, added an admin panel, added a lot of other features, and changed the UI. Yeah, I did that refactoring. And then, right now, farming will be refactored once again to use a lot of the knowledge that I gained along the way, and also to implement new features. Things that will change, like in the farming DApp, like the farming DApp will be divided into two softwares, one front end, one back end. That's the first place. then the backend will only be for like requesting data and taking care of handling like the smart contract, some special methods to distribute, and that will be taken care of by the farming app. Then the second thing is stuff will be added on top of, and it will be using the decks. So people that create polls, not like polls that appear, can be incentivized via the farming app. So new tokens can take advantage and like reward people for staking their token, so they will have like bonuses and stuff. And yes, I think like, in my opinion, actually that's a really good thing that I will be refactoring, because the code is not bad, but it could be really improved because things changed a lot and it needs to be evolved. Software needs to evolve over time. It needs to go to version 2, go to version 3. Like, it needs to improve and needs to take care of things users need. So I know some people are really against like change, okay? Are not prone to change, are not in favor of change, but sometimes change can be really beneficial. It can bring a lot of new things, it can bring a lot of new lights, a lot of new people, a lot of new things to the actual thing that you'll be using. That I think refactoring, like, I will be refactoring the actual farming in a couple of months, weeks, I don't know. And yeah, that will be really taken into consideration. So, and all of the other softwares, like the Explorer was refactored. Yeah, it was not done by me, but it was refactored. The chain was refactored, and I helped a lot refactoring the chain. Yeah, and it could be better, and it will be better over time, because like a year ago I was not really into the chain per se. I knew about the chain, I knew about some stuff, but I never really got in depth into the chain. But now I really know my way around the things, and that's why it will come. Like, it will be changing over time, it will be evolving, it will be going into a direction that people will be able to contribute to it easier and easier. So yeah, I think that's really one of the good things that we should be aiming. Yeah. I forgot where I was. Okay, sharing. Okay. How can one balance between the need to deliver features and the need to refactor the code? Okay. How can we balance? It's easy. You first thing is you develop the feature, and if a bug comes up, you refactor. Because if it's working right now, the first thing is to get the product out. The second thing is to make it better. And you can try to make the perfect product in the perfect world. It doesn't exist, and it's really almost impossible. I would say, like, you can develop the most amazing project, game, whatever, but that will take really, really, really long time. And do you have the budget to do that? And how will you explain, like, for example, for investors, how would you explain if you have like huge VCs behind you, and how can you tell we need the best product, and yeah, we should refactor everything, and it should be in like a diamond when it comes out? It's almost impossible. People will always find issues. Code will and can always be better. And yeah, I think like you first get the product, then you refactor. Or while you do a feature and you see like a huge pile of code, okay, I will refactor it, and you can do it like along the way, not one thing, like a huge thing that you refactor everything. You can do it like in small chunks while you develop a feature. So it's up to you how you will decide to make it, in my opinion. Okay, next question. Let's go. What kind of challenges might teams face when refactoring? How can they be addressed? They can face a lot of challenges. One in particular is the testing of code. I think unit testing, integration testing, like every type of testing, I think they can face a lot of issues because in some ways, sometimes it's a tedious process. It's not things developers want to do. It's like, in my opinion, it's not a thing that developers, okay, I'm gonna write a new software, a new product that makes the world better. Oh, but first let me do the unit tests. No one tells you that. No one does that. People want to have like the thing working, and then, okay, we should write unit tests right now. And it happens, at least I'm telling you from my experience, that happens to me. So yeah. How can we measure the impact or success of refactoring? It's easy. Of course, in backend software, it's a little bit harder, but at the same time, it's easier. If you have a DB connection and you take care of a bunch of data, the way that you can address that and like measure the impact or success is by seeing the time that it takes to retrieve an object or a bunch of data. And if the timing to process and handling that changed before and after the refactoring, you have done a good job. I think it should be called a success. And if you read the code a lot better, it's also an indicator of success, in my opinion. And like, if you make software reliable, faster, not prone to issues like errors and anything, I think you've done a good job. I can tell you, for example, the Explorer, the Phantasma Explorer, I was able to improve its performance for a certain transaction. That's the largest transaction that happens on Phantasma. That's the inflation, and it took one of them took 76 seconds to process. It's not a lot. It's a lot, but it's not a lot. But I was able to reduce it to 46 seconds. And I think like it's amazing. I just refactored a method to be able to achieve that. Take that into consideration. And the Explorer needs a really huge refactor to be able to improve its performance overall. And the structure of the database should be changed, because the transactions have a lot of information, and that it checks a lot of information that it shouldn't be needed, in my opinion. And I think it could be really improved over time. Can you discuss the role of documentation in refactoring? Okay, documentation is really important, and I'm really in favor of documentation. If you have documentation, you know. Sorry, I changed the subject really fast. But changing the question is, can you discuss the role of documentation in refactoring? I think the role of documentation in refactoring is really important for everything. That's my opinion. Like, if you have documentation that explains how things should work and how they are supposed to work, and the method tells you what it's supposed to do, and if it's not doing that, you can refactor the method to do what it's supposed to do. And it really helps while changing things and making them better. And also, if you are refactoring, you can also refactor the documentation to fit the needs to your standards, the standards of the company that you are working for, or the project. So yeah, it really helps future developers to take a look at it and do the things that they need to do. Can you discuss, okay, this is answered, how do you approach refactoring legacy systems without much documentation? Okay, this is a really hard question. But how I will do it is trying to understand how things work. Like, those systems should be running and working, but you will always be able to run an instance on your computer and test everything and debug it and try to understand how the code works and navigate the code. And while you are doing that, you can write documentation and write the process that you are doing. So when you understand something, you can write it down and write the documentation for that. So you are writing the documentation and at the same time upgrading the system, refactoring it to changing from .NET 2 to .NET 8, because we are getting to the .NET 8. We are right now, Phantasma is using .NET 6, but we already have .NET 8. So yeah, and things like that. You should try to understand how things work. I know it can sometimes be really difficult, because I had the same issue with the Phantasma blockchain. There was not really a lot of documentation. There was some documentation, and it was kind of hard. The method were the names of the methods sometimes were self-explanatory what they should do, but it was hard at the beginning. And while you're doing the refactoring, you'll start to understand things, and writing unit tests, if they ever unit tests, it will be really easy to understand the code, because you know what they are testing. If they are done correctly, you know what they are testing, and you'll know what they were used for, so it will be easier. And yeah. Next question. What advice would you give to a novice programmer about to embark on their first major refactoring effort? Don't be afraid. Don't be afraid, don't panic. It's fine to look at it and be overwhelmed at first, but that's part of the job. And because I felt that way, and I know it's really how am I going to go about it? And you feel overwhelmed. Oh shit. But my advice is just start with a simple one. If you have a huge bunch of methods, classes, just start with a simple one, either a method that has a lot of lines or a class that you can change. Yeah, some small stuff, start small so you get rewarded fast and you don't feel okay, what the hell am I doing? Why am I doing this? It's not needed. If it's working, it's not needed. Yeah, but start slow and you'll get there. Start with a small class, then yeah, go up the ladder. Start with a small class, Then you refactor that class, write unit tests for that. Okay, done. First one. Now like 30 classes or more than 30 to go, but you'll get there. And yeah. Can you share any resources, books, websites for those? Yeah, like YouTube. I think YouTube is one of the best tools that we have for refactoring, for like learning, not learning how to refactor, because it's not, you cannot learn how to refactor. You learn how to code, how to improve your code skills, and then you refactor the code. Because refactoring is basically an upgrade of your code. Yeah. It's basically that. The resources that I shared already, it's like clean architecture, clean code, and some unit test books, some testing book for your language so you understand, or some documentation for the language that you are using. Because it's highly dependent on the language. Like in C#, you can create another solution, another project with the same name of the other one, but dot tests. Yeah. And then you can like basically copy the structure of the other one and do like a file by file testing. Yeah. In your opinion, what are the misconceptions about refactoring that you'll create? Refactoring is not a waste of time. I think I will leave it with that. Like, refactoring is not a waste of time. A waste of time is that if you don't refactor. Because if you don't have a software that needs to be refactored, not refactored, in the future, the future developer that comes in, or you that developed that, most likely you won't remember how the thing works. Yeah, so take that into consideration. Like, it's not a waste of time. And not a waste of resources. Because I know that you are spending some time refactoring right now and wasting time, per se, refactoring the code, but for the future, it will eliminate a lot of issues down the line, and it will be easier to debug. It will be easier to understand the code. It will be easier to add features. It will be easier to do everything with the code. Yes, it's, in my opinion, it's highly important refactoring the code, if it's needed, of course. How does refactoring contribute to software maintainability and extensibility? I think I answered that. Like, refactoring can be like changing everything and making it look better. Refactoring can be just upgrading a version and making that work. Changing methods, changing the way the method works to the real world, like improving its performance, security, and everything. And it will contribute certainly for the maintainability, because the code will be easier to read, the code will be easier to navigate, the code will be easier to maintain for the future, and it will extend its lifetime because you are always refactoring, upgrading to the next version, being on top of the new features. And yeah, I think it will increase the extensibility and maintainability because of that. Could you talk about some anti-patterns or practices to avoid when refactoring? Good question. If you are refactoring, don't write like, I'm sorry to say that, but don't write cheat code. Do it in a good way. Patterns, I think you can use like any pattern that you want. Maybe like write your names, write the variable names. It's not a pattern, but it's a practice. not to avoid, but to do. To avoid is like, don't write weird naming variables. Like, get your variable's name to the point and try to be the most precise. I know it's hard, but it will like really clean your mind in the future, and for other developers reading your code, it will be really easier for them. And while writing code, and this is an advice, while writing code, don't think about yourself. Don't think about you understanding the code. I know you will understand the code. It's easy. It was you that wrote it, but the code is not only for you. If you work on a company, yeah, people should understand without you need telling them how things work. Yeah, that's it. And let's go for the next question. I'm having fun. It's a lot. Jesus. How do you envision the future of refactoring, especially considering the rise of AI and machine learning in code generation and optimization? Yeah. I think it will help a lot. Like, people don't really like to write unit tests, and that will help a lot in terms of refactoring, because you wouldn't need to write like everything. You wouldn't need to, if it doesn't have unit tests, the AI can generate tests for you. And I can tell you, the refactoring that happened to Phantasma, like writing some unit tests, some code to the testings, AI helped me a lot, because it was a lot of methods. We increased from 26% to 81%. Right now we are at 77% because things were added upon and I wasn't writing unit tests. But once I get back, I will refactor everything slowly and write unit tests. Like, I will try to write unit tests for everything, because if we do have everything working, the tests will be a key for the success of everything, in my opinion. And I think that's it for today, guys. I hope you enjoyed. It was a really different episode. It was a really in-depth refactoring experience and pros and cons. I didn't talk about the cons a lot. The cons is, if you refactor a software that's working and it's in a good state in terms of readability, sometimes it doesn't need to change. Like, sometimes that software needs to upgrade the version. Yeah, and that's only that. And the cons is that you will spend a lot of money if you are working on a company and you are the owner or CTO, or if you are, and you will waste a lot of time, because it takes time to refactor. But at the same time, in the future, you will earn more time. You will earn time for implementing new things, implementing and debugging things, and spotting errors, spotting issues. Yeah. So do your part. I will be doing mine, and I will keep coding, and you should too. So see you on the next one, and I hope you enjoyed. Bye.